Hi guys, this is Miss Gold. Today's lesson is Module 2, Lesson 11, Comparing Bar Modeling Solutions to Algebraic Solutions. Your outcomes for today's lesson are students use tape diagrams to solve equations from the form px plus q equals r and p times the sum of x plus q is equal to r, where p, q, and r are small positive integers, and identify the sequence of operations used to find the solution. Students translate word problems to write and solve algebraic equations using tape diagrams to model the steps they record algebraically. Now, you'll notice in the outcomes we've called them tape diagrams, but they're also referred to as bar modeling. The purpose of this lesson is really to prepare you for a group activity that you're going to be doing tomorrow in class. So I'm going to go through the first example, and then what you're going to be doing in your groups will be similar. So you'll want to use the notes as a reference for the ones that you do in class. So all of the questions that we're going to be doing will all revolve around this scenario. John and Ag are summarizing some of the expenses of their family vacation for themselves and their 3 children, Louise, Missy, and Bonnie. Create a model to determine how much each item will cost using all of the given information, then answer the questions that follow. So here we have a list of their expenses. We have car and insurance fees were $400, airfare and insurance fees were $875, motel and tax $400, baseball game and hats $103.83, movies for one day $75, soda and pizza $37.95, and sandals and t-shirts $120. So we're going to use that information to answer the first question. Our scenario is, during one rainy day on the vacation, the entire family decided to go watch a matinee movie in the morning and then a drive-in movie in the evening. The price for a matinee movie in the morning is different from the cost of the drive-in movie in the evening. The tickets for the matinee morning cost $6 each. How much did each person spend that day on movie tickets if the cost for each family member was the same? What was the cost for the tickets for the drive-in movie in the evening? So let's start by highlighting some of the important information. We were told that they went to a morning matinee and each ticket cost $6 each. What we want to find is the cost of the drive-in movie tickets, and then therefore we also want to find what did each person spend on the day they went to the movies. So our unknown in the scenario is really the cost for a ticket to the drive-in. So let's first represent this using bar modeling. So the first thing I need to do is really define my unknown element. And so I'm going to use one block to represent our unknown element, which is the cost for the ticket to the drive-in. So we know that each person went to the morning matinee, which cost $6, and the drive-in movie in the evening, which is our unknown. So let's replicate this. And we're going to add on to it to represent the cost of the morning matinee. So I made this a slightly different size so that we could differentiate between our unknown element and our known element, the cost of the morning matinee. So this here represents the cost for one person. But if we look back to our original information, we know that they are a family of 5, so we need to repeat that 5 times. So I know that we need to replicate the cost of the drive-in ticket and the morning matinee 5 times. So there's 2 people, 3 people, 4 people, and finally 5 people. So if you look back at our original information, we were told that the amount they spent on movies for one day was $75. And so that really tells me the cost of the entire day, and therefore the length of my entire bar is $75. So the first thing I'd like to do here is take our bar, and why don't we make it easier on ourselves by rearranging the elements that are alike. So for example, the cost of the drive-in ticket, we can group those together and group our sixes together. So you notice that even though we have rearranged this, it's still a bar of the same length. So this still has a value of $75 for the entire bar. But now that I've rearranged it, we can see that we actually know what the value is for a portion of the bar, and that's this piece right here. So if I add up all of these sixes, and we have 1, 2, 3, 4, 5, 5 of them, 5 times 6 we know is 30. I can use that to figure out the length for the rest of my bar. And I would do that using subtraction because we have the whole value. We have the whole value and a portion of that. So we can use subtraction to find the other piece. So let's do 75 minus 30 leaves us with $45. So in this other section of the bar, we now can focus our attention just on this area. So if I count up my sections, I have 1, 2, 3, 4, 5 equal sections. So I really want to take the whole value of 45 and divide it evenly among the 5 sections. So that's exactly what we're going to do, is do 45 divided by 5, and we get 9. So that tells me the cost for the drive-in was $9. Let's answer the other question, how much did each person spend that day on a movie ticket? Well, if they went to a morning matinee for $6 and an evening drive-in for $9, they each spent $15. So let's take what we did with bar modeling and translate it to an algebraic equation. In an algebraic equation, the key element is a variable. So we first need to define a variable, and most commonly we use x. So let's say let x equal the cost of the drive-in ticket. So just to relate that back to our bar model here, that would make this x. So let's fill that in. So we have an x here, and when we rearranged, all of our x's were together. And notice what I had essentially was 5 x's. I need to make an algebraic equation. So let's take a look at what our bar consisted of. Well, we know that each person went to the drive-in and they also went to a morning matinee. The cost of the drive-in is unknown, and so we know that is represented by x. And they went to the morning matinee, which we know was $6. So this represents one person. But there were 5 people in the family, so we need to repeat this to represent each person. And we were also told that the family together spent $75 at the movies that day. The next thing we did with our bar model was to rearrange this, and algebraically what this is called is combining like terms. So what I'm going to do is put together my x's, and I can see I have 1, 2, 3, 4, 5 x's, and I have 5 sixes, so 6, 12, 18, 24, 30. So let's again refer back to our bar model. The first thing we did was we subtracted 30 from 75 to isolate our 5 unknown elements, in this case our 5 x's. So over here I would subtract 30. But essentially what we have to do to maintain balance in order to maintain balance within an algebraic equation, whatever we do to one side of the equation, we have to do to the other. And if it helps you, draw a wall here so that you can see or distinguish between the two different sides of an equation. So I subtracted 30 on this side, I would also need to subtract 30 on this side. And notice I'm going right below the other 30. The second thing I want you to notice is that this actually shows us some opposite operations of the same number. So if we have a positive 30 and a negative 30, that is going to get rid of it because 30 minus 30 is 0. And so we are just left with 5x. And so that's that idea of focusing our attention just on the 5 x's here, or the unknown element of our bar. And we know that we were left with $45. The last thing that we did was we divided our bar by 5 because there were 5 unknown elements here. So again, we're going to divide by 5, and like I said, whatever we do to one side, we also have to do to the other. And likewise, you'll notice that this is also going to have the same effect that our opposite operations here did. Here I have 5 is multiplied by x, and so we're going to do the opposite operation, which is to divide by 5. So 5 divided by 5 is 1, so I'm going to cancel these out and make it 1 times x, which is x. And 45 divided by 5, we know is 9. So this is how we could answer this question algebraically. The last thing I want to do is actually give a worded answer because we started with a word problem. So we need to make sure we always put it back into the context of the situation. So each person spent $15 at the movies. The drive-in cost $9 per person. In this lesson, you have learned to use tape diagrams to model and identify the sequence of operations and then translate that to an algebraic solution. The goal in solving equations algebraically is to isolate the variable. The process of doing this requires undoing addition or subtraction to obtain a 0 and undoing multiplication or division to obtain a 1. The additive inverse and multiplicative inverse properties are applied to get the 0, which is the additive identity, and the 1, which is the multiplicative identity. The addition and multiplication properties of equality are applied because in an equation A equals B, when a number is added or multiplied to both sides, the resulting sum or product remains equal. So as I said in the beginning of the lesson, you need to have this example available because you're going to be using it tomorrow for our group activity.